What I want to do in this lecture is essentially to complete our review of JavaScript, in particular to look at the JavaScript functions.
Recording in progress.
So I just want to complete this set of slides here. And when we've done that, then if I go over to the lab exercises, there's a new lab exercise which covers the topics that I'm covering in the slides. So that's the plan. Now, when I lectured TE last, I did work my way through some of these slides dealing with JavaScript functions. So I'm going to fast forward on to where I left off, which was talking about higher order functions. And if you remember, a higher order function is a function that takes another function as a parameter. So we have the main function and we have the function parameter. The function parameter we refer to as a callback. So the main function invokes or calls the callback at some stage within its body. And we'll see this programming style an awful lot in this module. So you need to get used to the kind of pattern that you'll see. Typically, the callback is implemented as an anonymous function, and we could use the arrow function style or the function declaration style. It doesn't really matter, but we tend to, in most cases, use an anonymous function to represent it. Now, just by way of example, really, I decided to use the array data structure as a context for explaining higher order functions, plus a few other things as well, as it turns out. And the array data structure has a number of methods which take a function as an argument. So that satisfies what we're trying to achieve here. And I'm listing 4 of them there. There are others, though, for each method: filter, map, and reduce. Now, so there is a code archive that comes with this or associated with this set of slides, and you'll get the archive in the second lab. And when you do, you unzip it and import it into VS Code. And the structure of this archive is similar to the previous archive that I gave you. So we'll be using the live server here as well. So I've got an index.html, and it has various script tags in it, which we will enable kind of one by one. Initially, the script tag that I've enabled is, have I got any of them? Yeah, I've enabled this script tag here. And that is referring to this file here. No, it's not. It's referring to this one. So I need to, sorry, I'm just studying something for a second. Oh yeah, okay. Just going to leave that open. Now, just to explain the background to these examples that we're going to work our way through. There is this web API called the Random User Web API. And what it will do is, if you send it a request, it will randomly generate user profiles. By user profile, I mean a username, first name, second name, age, date of birth, and various other properties of a person. And it will return an array of those user profiles. So a user profile will be an object, and it will return an array of them. So, for example, even from the browser, we could type in this URL, and the URL has a query string part to it. And what this query string is telling the Random User API is that I wanted to dynamically, randomly generate 10 user profiles. So if I actually just click on this hyperlink, it'll open up my browser tab. And there you go. This is the data that it returns back. which is in JSON format. We haven't covered JSON formally, but JSON is essentially JavaScript object notation. And if I literally copy this, because it's we couldn't really interpret that easily. If I copy that and if I go on to the web and find a website that will format that for me, and there's lots of them out there. So I Googled earlier on Json Formatter, and really the first one will do fine. There are other ones though. And what you can do with the Json Formatter is paste in your JSON data and then ask it to format it. And this is the nicely formatted JSON data that's returned by the random user web API. And it so what it returns is an object, and the object really only has one key called results. And that key is referring to an array where the entries in the array are individual user profiles. So this is kind of one user profile, roughly around here. Okay, so that's by way of background. This is a random user web API, which we will make use of. What I'm trying to describe here is the architecture, if you like, of these samples that we're going to step through. And it's quite an elaborate architecture, to be fair. So here I have my live server, which is that plugin that we installed into VS Code. But essentially, it's just a standard HTTP server. Here's my browser, and here's my random user web API. So the way these samples are going to work, my browser is going to send a request to the live server for the index.html file. It will return that to the browser. As we know, in the index.html file, there's very little HTML, but there is a script tag. And the script tag will cause the browser to send another request back to the live server for the JavaScript file. The JavaScript file will be downloaded to the browser, or uploaded, I guess, to the browser. And then the browser is going to run the script. And in our case, the script is going to make a call, a HTTP call to our random user web API. That's going to return some data, and the structure of which we kind of got a glimpse of there a minute ago. And all I'm going to do with the data is process it and maybe output something to the browser's console. I'm not going to get into displaying something on the browser's web page because that's unnecessary complication, really. So that's the architecture of what's going to be going on in the background. So if we, but just by the way, if you're using a web API and you want to discover the structure of the data that it returns back to you, you could do it the way I did it there a moment ago, type in a URL into an ordinary browser tab and then grab the response that comes back and paste that into a JSON formatter website. You could do all of that, but it's a little bit long-winded. There is, for example, a tool called Postman, which you may have used before. It would be a much better way of playing with web APIs, and you will use Postman a lot in the second half of this. You'll be using it a lot in the web API, in the web app dev module, but later down the line. So we needn't worry about Postman right now anyway. Now back to our code samples. There's a number of them, and the first one I'm going to look at is what I'm calling the base example, because all of the other examples kind of build on what you learn from the base example. The base example is going to be using a function that is built into every browser called the fetch function. Again, you may have used this before. The fetch function allows you to make HTTP calls from a browser. So in other words, it's going to allow us to implement this communication here. And also I'm going to be using the for each higher order function, which I will use to essentially iterate over the user profiles that are returned by the random user web API. And I think I just display the person's name, first name and second name, and that's about it. So let's look at this script here. Okay, which is this one. And also maybe if I just flick over. So sorry, what should I do now? I should start my live server so that it can serve the index.html file to me, et cetera, et cetera. So if I click my go live link down here at the bottom. And what we're really interested in now is in what's happening in the browser's console. I need to go back to my index.html and change it to refer to this script here, because we looked at this script last week. Sorry, we looked at this script last week, so we don't need that. This is the script, sorry, that I need to look at. Save that. And here's the list of users, and I'm just displaying their name. Okay, so I'm extracting that from the full user profile. So let's look at the code that actually produced this list of names. So here's the fetch function. As I said, it's built into the browser, and you give it a URL, and that's you can see it's my random user URL, and I'm asking it for 10 profiles. I'm asking it for 10. Sorry, I'm asking, well, it doesn't really matter, but I'm asking it just for 6 user profiles. Now, clearly the fetch triggers a HTTP request from the browser, and the response from the web API is going to be sometime in the future. In other words, it's going to be asynchronous. So the way we handle that, or the way the fetch tells us to handle that, is to chain on an invocation of a special method called then, and you pass the then method a higher order function. So higher order functions are kind of all over the place now in this illustration. And here's my higher order function. And what this higher order function does, it does 2 things really. When you're communicating with a web API, it's possible that the response that comes back is going to be fragmented, because as data is traveling across the network from the web API to our browser, it may be fragmented in transit. And so when it eventually arrives at our browser, the browser needs to reassemble that fragmented data. That's number one. Number two, what we're really interested in is the body of the response that comes back. We're not necessarily interested in the HTTP headers. We may be, but in our case, we're not. So we need to just take the body of the response that comes back, which, as we saw there a few moments ago, is going to be a JSON body structure. And we need to convert, or that JSON needs to be converted into an ordinary network of JavaScript objects so that we can process them. Now, all of that work is essentially done by the code that I've highlighted here. And what it eventually returns is the body of the response that comes from the random user web API. You then take that response, that body response, and you process it here. Okay, so it's in terms of the code, it's quite tricky, but you could essentially regard all of this code here as kind of boilerplate. So if I just pick up the story from here, let's say, here we've got a second invocation of this special method called then. And as we saw up here, then always expects a callback. So here is my callback yet again, implemented as an anonymous function using the arrow style. And this is where I'm kind of processing the data. This anonymous function is invoked by the then method, and what it passes into it is the body of the response that came back from the web API, where that body is formatted as JavaScript. And in our case, as we saw a few moments ago there, is it still in my browser? Let me just see. In our case, its response body is going to be this entire structure here. And we can see that within that response body, there is a key called results. And you can see that here I am going response body dot results. So now profiles is going to be pointing at the array of the array of randomly generated user profiles that the web API created for me. And I now want to process those. So really the only relevant part in terms of array higher order function methods is kind of this part here. So profiles we know is an array of objects. I'm calling for each on it. The for each method yet again takes an anonymous function. And here's our anonymous function. And that anonymous function is invoked by for each once for every entry in this array. And we kind of know how for each works, I think, from the previous lecture and from other stuff that you've done in JavaScript. So all I'm doing is I'm doing a console.log in for each. And if you see the console.log, it looks like it's extracting the person's title and their first name and their last name. And that's consistent with what we see over on the right. And I did ask it for 6 profiles. So I've got 1, 2, 3, 4, 5, 6. That looks right. I'm going to pause for a second in case there are any questions. So potentially there's a couple of things that are new here. One, this whole fetch idea. That's how we communicate that's how we make HTTP calls from a browser. This coding is quite sophisticated, I suppose you could say. What we're doing here is what's called method chaining. We're chaining on an invocation of the then method to the response that's returned by fetch. And whatever the then method returns, we're chaining on another invocation of then. This is really kind of, as I said, it's boilerplate code for how you implement communication between a web browser and a web API. Just to warn you about something if you're playing with this in your own. So if I do a manual refresh, sometimes, okay, it's behaving now, it's generating. You can see it's generating different names every time. But when I was playing with this last week, every now and again, you would get back what's called the CORS error. But really, you just keep pressing command refresh to get it to work. Doesn't seem to ever want to generate the CORS for me here. Now, I'm not sure why I was getting the CORS error. Perhaps I was on a different network, actually, as I think about it. Either way, it seems to be behaving this time. Right. that's my base example. And the base example, my objective was to show you how to communicate with the web API. And we saw that's what we use the fetch for. And I also just wanted to demonstrate the array for each method as a very simple example of a higher order function. I am interchanging the word function and method here now, but for each is essentially implemented as a function behind the scenes. But the function as a parameter takes a callback, and we saw that. In passing, we saw that the then method associated with fetch, that also takes the callback. Let's move on to filter. Filter is another higher order function associated with the array type. It also takes the callback. The purpose of the filter is to take an array, which I call the source array, and to pick out certain elements within it based on some condition, and create a new array, which I call the output array. In the output array, it will put references to the elements of the input array that satisfy the particular condition. The way we express the condition is through the callback. So I'm saying here, it selects entries from a source array or input array based on some condition or criteria, and it places references to those matching entries, if you like, into a new array, which I'm calling the output array, and then you can do whatever you want with that output array. The selected entries, I'm saying, are added to a new array. Okay, I've already said that. The source array is unchanged, so we would classify filter as being a pure function. Doesn't make any changes to state outside of its scope. And we're asked to look at this sample. So let's do that. Back to my index.html. Change it to now refer to different script. And let's glance over the script. It will have a lot in common with the base script. So again, I'm using fetch. Again, I need to sorry, now I'm just checking something. Yeah, I don't really need that now. You can ignore all of that because this is just what I was talking about there a while ago, actually. This CORS error that I was getting. So I don't think I need any of that now. Let's hope it doesn't come back to bite me. Can take all of that. And so we've seen this before now, the then followed by another the then invocation. Just in passing, then takes a callback, and I'm implementing my callback using the arrow function, but I'm also using the kind of shorthand version of it, where you can drop a lot of the syntax. So the long-winded form of what I have in this line here might be put your parentheses around the parameters to the callback. And use your curly braces. Move that up. Have an explicit return. Now, have I broken anything? Did I lose my... Sorry, no. I've got a syntax error somewhere. Just bear with me. I think it's there. Never a good idea to instill something it doesn't like. Should I have done this at all? Okay, there's a problem there as well. Don't think it's happy still. Right. That's the long-winded version of the shorthand form of the arrow function. The shorthand can be a bit off-putting, I think, but so if I just go back to the shorthand, just having shown you the long-handed version. So I'd undo all of those changes. Did I save it? I save it. And then just undo everything. Back to here. Okay, moving on. So that we know now what generally anyway what the purpose of that's come back in again. Gosh, sorry now about this. I'm going to take all of that out. Right. Here's where we're more interested in though. Here's eventually we have the array of profiles, the full array of user profiles generated by the web API. I'm only doing a console.log just for debugging purposes, I suppose. So we're sure on the structure of the data that comes back. And so moving on to the filter. So I've got an objective here that I want to find all female profiles. Now, I could have programmed that objective by means of a standard for loop, okay, which I've commented out, but that would be the non-JavaScript way of doing it. The JavaScript way of doing it would be to use the filter method. So I've got my full array of profiles. That's my source array or input array. I'm invoking the filter method on it. The filter takes a callback. Here's my callback. And in the body of the callback, you eventually have to return a Boolean. And if the Boolean returns a true, then the current element of the array that's being processed is going to be added to my output array. So what the callback is doing is we can see it's passed in the current profile entry in my array that's being processed. Again, I'm just doing a console.log for debugging purposes. I'll take that out maybe. And in terms of determining whether the current profile that's being processed should be included in the output or not, it looks like I'm checking the gender property to see if it's equal to female. And I know that's how I determine whether a profile is female or not. When I examine the profiles, the full list of profiles that are outputted by this console.log, here, I can see when I examine it, I see that there is a property called gender, and it's set to either the female or male. In fact, let's do that. So here's the full 10 profiles. If I just pick any one of them, you can see here gender. I happen to have picked one, but other ones would have gender equal to male. So in terms of the filter higher order function, you pass it a callback, and the callback has to return a Boolean, which it is doing in my case. Here's a second example. My objective here is I want to find all male profiles under the age of 40. And now my filter function which I can use again on the full array. And I'm passing it a callback, of course. Here's my callback implemented as an anonymous arrow function. Again, I'm using the shorthand version of the arrow function. There's no curly braces being used here. There's no explicit return statement. By default, the return value of this callback is whatever that expression evaluates to. So that looks like it should work for me. So this console.log should only output the set of profiles that I'm looking for. And if I look at the second console.log in the browser, which I think is this one here. And if you examine them, it's definitely male. Where's age? Why am I not seeing age? Should be there somewhere.
On the date of birth, no?
Is it under date of birth? Is that what the code said? Yeah, there you go. Good, well done. Do I have a third example? No. Okay, so that's filter. Filter takes a callback, but the purpose of the callback is to return a Boolean and express the condition determining whether the current entry in the array is added to the output array or not. Map is yet another example of a higher order function. What map does is it creates a new array as well, but there will be as many entries in the new array as there is in the input array. And the entries in the new array, they will be computed by the callback that you pass to it, where the callback will take the corresponding entry in the input array, do some computation on it to compute a value. That value could be a primitive, or it could be an object, or it could be anything really. Whatever it computes, the result is put into the output array. So there's a one-to-one comparison between the input array and output array in terms of number of entries, and the entries in the output array are computed from their corresponding entry in the input array. That's what map does. And this notion of mapping over an array is a common feature across all languages. So it creates a new array, typo there, based on the source array. And again, it doesn't make any change to the source array. So let's look at the example. Close off some files. So we'll just pick up the story here. And I've got my foot array of profiles, and my objective is to create an array of profile emails. So I just want each user's email, and I think I put their name as well, into the output array. So my output array should be an array of objects where each object just has a person's name and their email address, none of the other properties. Again, if I didn't know anything about map, I could implement that objective using some sort of for loop, but that wouldn't be the JavaScript way. So here we go. We're calling map passing it a callback, as all of the examples are doing. And my callback, quite simply, is returning an object of this structure. So there isn't a whole lot of computation going on, but that's okay. So the objects in this array here are going to be have this structure, and there's going to be one for every user in my input array. And then I console.log that. And if I look at the, did I save that? Yeah, if I look at the browser's output, that's wrong, sorry, wrong one. It's the second one. Okay, so the shape of that object corresponds to what the maps callback produces. Do I have a second example? Objective. Create an array with profiles ages. Okay, so in this case, this output array is just going to be an array of integer values, where the integer represents the person's age. And so, you know, it's the callback is as short as that, really. And so the console.log here, sorry, here generates my array of ages. That's mapping. So filtering always produces potentially a smaller output array than the source array, whereas map has the same number of entries in the output array as the input array. The next higher order one that we want to look at is called reduce, and this is a trickier one really to wrap your head around. The overall idea is you have your input array and you want to produce or generate an accumulator value from that source array. So the way you produce the accumulator, and what's an accumulator? An accumulator is something that we incrementally add to, if you like. So as we go through each entries in our source array, we're going to be updating this accumulator based on each entry in the input array. And so the updating of the accumulator is what will be done in the callback that we pass to reduce. The other thing you need to tell reduce is what is the initial value for your accumulator, and that can be that is important as well, that you get that right. So unlike filter and map now, what reduce takes is it takes a callback, which they all have so far, but it also takes, way down here, takes the initial value for your accumulator. Now, working out what the accumulator is in terms of its initial value, that can be straightforward, or it can be a little bit more, involve a little bit more thinking on your part. But in terms of the overall, sort of parameters that you pass to reduce, you pass it a callback, and the purpose of the callback is to update the accumulator. And you also pass it the initial value for the accumulator. And so the way the reduce works is, starts off with this initial value for the accumulator. It passes that initial value by means of the first argument to the callback. So the first argument of the callback now is always going to be essentially the, if you like, the current value of the accumulator. The current value for the first invocation is going to be the same as the initial value. You also pass it the element of the array that's being processed, and optionally you can pass it these two arguments as well, but in most cases you don't actually use them. So the important ones are this one and this one. In the body of the callback, that's where you compute how to update the accumulator value that was passed into you. And critically, the callback needs to return the updated accumulator value. That updated accumulator value then becomes the first parameter in the next invocation of the callback with the next element of the array. In here, we compute how to update the accumulator, return the updated value. That's passed in as the first argument in the next invocation of the callback, and on it goes. So as the developer, what you've got to decide is, what is the structure of the accumulator and what's its initial value? And obviously as well, how do I decide how to update it in the body of the callback? Okay, so let's look at an example. And again, we'll kind of take it from here. So the first example is the kind of 101 example. What's my objective? My objective is to compute the average age of all the user profiles. And we know how to do that. We simply just add up the ages of all of the users and then divide by the number of users. So what the reduce higher order function will do for me is I can use the reduce to compute the total ages, if you like. That's my accumulator. Again, all I'm saying here is, well, you could do it if you wanted it in a for loop, but we're not going to take that option. So here I'm calling reduce. And my initial value for my accumulator is 0 because my accumulator is just going to be an integer. And in the body of the callback that I pass to reduce, here's the callback. Total is going to be the total ages so far, which initially will be 0, the current profile that I'm processing. And you can see in the body of the callback, what I'm returning is my updated accumulator. My accumulator again is the total ages of all of my user profiles. So I'm taking total, which is passed into me, and I'm just adding the person's age to that, and I'm returning that. So again, without overdoing it now, really, the first time this callback is invoked, total is going to be 0. And what the callback is going to return is essentially the first person's age. The next time the callback is invoked, total is going to be equal to the first person's age. Then it adds the second person's age to that and returns it, which means the third time, the third time that the callback is invoked, total is now going to have the ages of the first 2 users that I've processed so far, and on it goes. What does reduce return? What reduce returns is the final value of my accumulator. And in my case, I'm just taking that value and I'm dividing by the number of users in the array, the profiles array, to compute my average. Did it do that? Now, so the average is whatever I got here. And you could confirm that for yourselves by going down through the individual ones of them if you want to. That's the simplest example of using reduce. Often the most difficult part of reduce is working out or identifying an opportunity to use it and then implementing it. But even identifying an opportunity to use the reduce can actually be the difficult part of using reduce in the first place. If I tell you use reduce to do to solve some problem, then I've already told you reduce, the use of reduce is the approach to the answer. But if I just describe the problem, actually deciding or working out, I can use the reducer method to do that for me. That first step can often be the difficult step. Let's look at another example. In this case, I want to find, what is it? I want to find the youngest profile in the set of profiles. Now, realizing that reduce can actually do that for me would not be an obvious thing, I think, but in fact, we can use reduce to do it. And let's bring in the code. So the accumulator now, you see the notion of the accumulator now slightly breaks down in terms of our normal understanding of an accumulator. Our normal understanding of an accumulator is it's something that's updated every time we process an entry in our source array. But it doesn't work like that in this example, as it turns out. So let's examine it. So the initial value I give for my accumulator is 100. Why did I pick 100? Because I know that none of the user profiles is going to have an age greater than 100. And in the body of my callback that I pass to reduce, what I'm doing is I'm always checking to see, is the current person's age less than the lowest age that I have found so far? And if it is, then return that new younger age as the return value from the callback. And as we know, that's now passed in as the newest minimum age that I've found so far. And I again compare that each time I compare that to the current person's age to see, is the current person's age less than the minimum that has been found so far. So my accumulator in this case represents the lowest age that you have found in the array of profiles so far. It's not something that we keep changing as such, which is the normal notion of an accumulator. So the tricky parts are A, realizing that reducer will solve this problem first. B, setting the initial value to 100. If I set the initial value to 0, then based on how I've implemented the callback, clearly I'm not going to find anybody whose age is less than 0. So it never changes. Each time the callback's invoked, min, which is my accumulator, is going to be 0. And the overall result returned by reduce is going to be 0. That's why I set it to something that I'm definite that I will find at least one person whose age is less than 100. I think I've explained this ternary operator to you before, essentially a shorthand for an if-else. I'll just give you an opportunity maybe to quiz me on how I've approached this particular solution, if you have any questions on it, I wonder. No. My third example is even more complicated again. So let's step through this example. In this example, what I want to do is I want to go through all of the profiles and put them into groupings based on age. So I want to find how many users are younger than 25 or younger. How many are aged between 26 and 50? These are just arbitrary ranges that I've picked. how many are in this age group and how many are in this age group. So this is the structure of my accumulator. And so this object, if you like, this is going to be its initial value. And as we work through the users in the array of profiles, I'm going to be incrementing one of these values based on the age of the person that we're currently processing. And every time my callback is going to return the updated structure. So I've also just, for convenience, I've defined some convenience functions for myself. So I've got what's this do? Well, that's not a function. What I've just done here is I'm extracting all of the keys from this structure up here. So that variable is just going to be an array containing these strings here for me. I've got a little convenience function. I think this is the convenience function that I defined for myself. What this function does is it's passed an integer, which is representing a person's age. And it decides just by a series of if-else statements. I could have used case switch. It's checking to see which of the categories of my 4 categories, these are my categories up here, which of the categories does it fall into? And based on that, it then returns, what is it returning? That age category, if that's, oh yeah, it's picking out one of the entries in this array. So really, I guess what it's going to return, what this convenience function is going to return is one of these kind of strings here, because these strings are the entries in this array. So that's kind of tricky stuff here, but you can study it later on yourselves. That's my convenience function. And eventually I get to the reduce part, which is this. And I have a console.log as well. The initial value for my accumulator is that structure up here. And in the callback, in the callback, I first of all find, I use my little convenience function. I pass in the age of the current user. So that's going to return the key in my accumulator that this person's age falls into. And what I'm doing on this line here is I'm incrementing the value associated with that key in my overall accumulator structure. So this expression here is going to be incrementing one of these values here. And it works, and critically, it returns the updated accumulator. People often forget about the return statement. So we don't usually, then this finishes up as being undefined. Now, that's about as elaborate an example of using the reducer that you would come across. We won't actually be using reducer that much. We certainly will be using filter and map, and you will be using filter and map in the web app dev module. So if you can at least understand how this code works, then that's really sufficient in terms of higher order functions and the reducer method. But really, my overall objective here was to explain higher order functions in general. And we just looked at a specific use case. And, okay, the reducer it's a nice method and it's a very useful method. And you should be able to understand it based on what I've just shown you. And the exercises in the lab get you to try and apply these to a slightly different use case, a different web API. So I won't talk over this slide because we've went through quite a lot there now, and it's heavy enough going at the latter end of it, I think. Okay.